Okay, number 6, second part of our factoring trinomials classwork. We do have a leading coefficient of, oops, forgot to take a picture of it, leading coefficient of 2. We always want to check for a GCF. Hold on. Okay, leading cofactor, or if leading coefficient of 2, we always want to check to see if the other two numbers are divisible by that. Thank you. I'll leave it there. 2 is not going to be, 17 is not divisible by 2, 15 is not divisible by 2, so we can't factor it out as a greatest common factor. So we need to do 2 times 15, which is 30. We need to find the two factors of 30 that add up to 17. In this one, it is the two factors that we just used, 2 and 15. But if you don't know, you can just write out all the factors of 30. 1 and 30, 2 and 15, 3 and 10, 5 and 6. I believe that is it. But obviously 2 and 15 are my two numbers there. I'm going to use the shorter method that I prefer, which is just to put these two numbers, 2 and 15, using the variable y into binomials. Y plus 2 and y plus 15. And then, because my leading coefficient is 2, I need to divide both of these numbers by 2. So whenever your leading coefficient is anything other than 1, you've got to divide your two numbers by it. So 2 divided by 2, that's 1. I can do that. If it's not divisible by 2, 15 is not evenly divisible by 2, then you need to take the 2, or whatever the number is, and put it in the front of the first term of the binomial. 2y plus 15. And that is what I get. Thank you. Moving on to number 7. On number 8, we have a leading coefficient of 14. And my other variables are not divisible by any of the factors of 14, so can't GCF. So I've got to do 14 times negative 3, which is negative 42. And the two factors of negative 42 need to add up to 19. The only way that's possible is if one of the numbers is negative, because if I multiply into a negative 42, one of the numbers has to be negative. So what are the factors of 42? There's 1 and 42, 2 and 21, there it is, 3 and 14, 4, nope, 5, nope, 6 and 7. Okay, if I do minus 2 and plus 21, 21 minus 2, that is 19. So they add up to 19, and they multiply to negative 42. So now I'm just going to put them into the binomials. My variable is x. I'm going to do x minus 2 and x plus 21. Now I'm going to divide both of them by 14 because my leading coefficient is 14. Anytime it's anything other than 1, you got to divide by it. Divide by 14. Divide by 14. This one's a little bit trickier because I need to reduce these factors, these fractions. So 2 over 14, that can be reduced to 1 over 7. They're both divisible by 2. 2 divided by 2 is 1, 14 divided by 2 is 7. 21 and 14 are both divisible by 7, so you get 3 over 2. 21 divided by 7 is 3, 14 divided by 7 is 2. They're equivalent ratios. They both are going to equal the same decimal values, but they're augmented forms. The larger form, 2/14, is in an augmented form of 1/7. Again, they're still the same decimal. They're just a equivalent fraction. Thank you. All right, so now I'm going to have x minus 1 over 7 and x plus 3 over 2. Thank you. Just leave it in the bare, okay? Don't take all the stuffing out. But we can't have these denominators in our answer here, so we need to move them to the front of each binomial. This becomes 7x minus 1. This becomes 2x plus 3. And that is my answer. There is the long way to do this. You can replace the b term, 19, with 21 and negative 2, 14x squared plus 21x minus 2x minus 3, and factor by grouping. That also works. Thank you. This is a 7x that is common on the first group. I get x plus 3. Excuse me, 2x plus 3. And then if I factor out a negative 1, I get another 2x plus 3. Get the greatest, or excuse me, the common binomial of 2x plus 3. And the remaining factors are 7x and a negative 1. We get the same answer that way. Lots of different ways to do this. Hopefully you're getting one way that works for you. Let's move on. Number 8, our leading coefficient here is a 3. Can I divide everything by 3? I can divide 30 by 3, but I cannot divide 19 by 3, so there's no greatest common factor, unfortunately. So I'm going to do 3 times 30, which is 90. I'm going to find the factors of 90 that add up to 19. So what are the factors of 90? There are quite a few of them. 1 and 90, 2 and 45, 3 and 30, 5 and 18, 6 and 15, 7, no, 8, no, 9, yes, 9, and 10, and from there we just go back down, 10, 9, 15, 6. Thank you. So which ones add up to 19? 10 and 9, or 9 and 10. I'm going to use my shortcut, well, what I call a shortcut anyway here. I've got my variables x, so I'm going to have x plus 9 and x plus 10. But I have that leading coefficient is 3, so I have to divide both of these by 3. Thank you. And 9 divided by 3 is 3. 10 does not evenly divide by 3, nor does this fraction reduce, so I just need to take this 3 and put it up front there in the binomial. I get 3x plus 10. Done there. If you prefer replacing your b value, you can do that, where you get 3x squared plus 9x plus 10x instead of 19. You still add up to 19, but just replacing the b value and then factoring by grouping. I get a 3x on the first group, and then I get 10 on the second group, and they both give me the same binomial of x plus 3. So I get x plus 3, and 3x plus 10 is left over. Same answer either way. Okay, number 9, we have our leading coefficient is 21, and see, no, they're not all divisible by anything. No greatest common factor. You always want to check for that greatest common factor. Always check for it. If it's not there, we've got to do 21 times 20, or a times c. It's going to be a negative 420. 20 times 20 is 400. So if I have 21 times 20, that's just one more 20. Give me 420. They need to add up to negative 16. This is one of those ones where a lot of students will be like, there's no way I can figure that out. It takes time. You have to know your math facts. You have to know your multiplication tables, division. But if I know at least 2 of the factors, I know there's 21 and 20, that gives me at least 2 options. 21 and 20 is there. So what are the other factors of 420? Well, there's 1 in 420. There's 2 in 210. 3. It's a lot of very similar to the factors of 42. 3 in 140. or 3 times 14 plus 0. No 4 that I know of, maybe though. 105 actually, yeah. 400 plus 20, yeah. But those aren't getting me anywhere near to negative 16. We need them to be closer to 21 and 20. 5 definitely have there, goes into 48 times, so 84. Now we're getting closer to numbers that might possibly add up to negative 16. 6 and 70. 7 and 60. 8. Does it go in there? Let's see, 8 goes into 45 times the remainder. Nope. So that is not an option. There you go. 9. No, 10. Yes. 10 and 42. 11. No. 12. Yeah, 12 is something. 12 goes into 43 times, 36, and that would be 6, 0, 35. 12 and 35. That's really close to 16, isn't it? Honestly, when I'm doing this myself, I just break down the factors of 21 and the factors of 20. What are the factors of 21? What are the factors of 20? Well, this has 3 times 7. This has 4 times 5. So I can move these around to either side. So if I take this 4 and trade it with the 7, then I would have 3 times 4 and 7 times 5, which is 12 times 35. That was something that was close. Let's try another combination of these factors. Let's switch the 5 and the 3. So that would give me 5 times, oh, that's the same thing. How about switching the 5 and the 7? So that would give me 3 times 7, or excuse me, 3 times 5 and 4 times 7, 15 and 28. Minus 10 is 18. That's close. That's 13. Let's see here. How about if I take one of the factors of 4, which is 2, I leave this with 2. That would be 10, though. How about 14? Because I know if I did 2 times 7, I would have 14. 2 times 7 is 14. Let's bring the 3 over here. That would be 30. There it is. 14 and 30. Yes, that was difficult to find. I think it's good for developing your number sense and good for your brain overall. But it is difficult. That's one of the more difficult ones I've seen in a long time. 14 and 30 was hard to find, but we found it. Which one is negative? It's going to be the 30 because 14 minus 30 is negative 16. Now I can just find my solution or my factors by plugging them in with the variable z. Z minus 14, or excuse me, plus 14, and z minus 30. And we have to divide by our a value, which is 21. 21. Got to reduce those fractions. Z, 14 and 21 are both divisible by 7, so that would be 2 over 3. And z here, both of those are divisible by 3, so that would be 10 over 7. And now that I've reduced the fractions, I can get my answer where I move the 3 up in front and the 7 up in front to get 3z plus 2 over, or times 7z minus 10. There it is in all of its glory. If you did not like that method, you can use a guess and check method, where you just try different factors of 21. Let's say I did, well, there was 3 and 7. That would be my natural choice here, which I use guess and check, honestly. 7 and 3, and then what are the factors of 20? Well, there's 5 and 4, or 2 and 10. So you could try 5 and 4, and you could see if I were to multiply these out, and I would have to make one of them negative to get negative 20. Let's see here, negative 5, positive. Would that give me the negative 16? Obviously, I get the 21z squared, and I get the negative 20, but do I do the 7 times 4 and the 5 times 3, the 28 and the 15, do those add up to negative 16? No, they don't. So I try different factors of 20. 7 and 3 are the only factors of 21, so those have to be either 21 and 1 or 7 and 3. So I'm going to try 10 and 2. I will do 10 here, 2 here. One of them has to be negative, so make that negative. And when I do multiply that out, I get 14 minus 30, which is negative 16. And that's how I do mine, is guessing and checking. But you really have to have the number sense down. In other words, you have to know your multiplication facts very well. Let's go to number 10. On number 10, oops. How do I do this? Hold on, let me rearrange here. Okay, last one. We're going to do 18 as our leading coefficient here. Is there any greatest common factor? 31 is prime, so no. They all three have to have the same common factor. So I'm going to have to do 18 times 6, which is 60 plus 48, 108. And I need to find the factors of 108 that add up to 31. And I'm going to go through that method of using the factors of 18 and 6. The factors of 18 are either 2 and 9 or 3 and 6. This has got 2 and 3. We could also use 1 and 18 or 1 and 6. I doubt that's going to give me 31 though. So I'm going to try some other combination here. Let's see here. If I were to do 9 times 3 is 27. 27 and 4. I did this 9 and the 3. That's 27. And then I did the 2 times the 2. That would be 4. And that adds up to 31. So those are my factors, 27 and 4. That looks easy, but it really is difficult to do, to find those factors. So you really have to practice your number sense. You got to know your multiplication tables. I sound like a broken record, but it's the truth. Okay, now that I know those numbers, here I can just put them into the binomials. That's my variable x. X plus 27. They're both positive because they add up to 31. And x plus 4. And then I've got to divide by 18. Divide by 18. And those can be reduced. These are both divisible by 9. This would be 3 over 2. This would be both divisible by 2. So it would be 2 over 9. And we've got to move the denominator over to the front. So I got 2x plus 3 and 9x plus 2. Here it is. The guess and check method, I would just find the two factors of 18x squared, 2x and 9x, and then find the factors of 6. It's going to be 3 and 2. So try 3 and 2. I know they both have to be positive to multiply to 6, positive 6. And I do 2x times 3, that's 6x, and 2x times 2 times 9x is 18x. Does that add up to 31? No, it doesn't. So I got to try again. I'm going to find a different order here. I already know the answer, obviously, but when I try this in this way, and I do 2x times 2 is 4x, and 3 times 9x is 27x. Does that add up to 31? Yes, it does. So that's how I would do it with guess and check. Just guess which two factors go first to make 18x squared, and guess which two factors make 6. Put them in there, multiply the outsides and the insides. If they add up to the middle, you're good. If not, you got to try a different combination. That's how I do it. Good luck. I hope to be back as soon as possible.